everyone, and good evening. So, as you're probably like, you're coming on again? Yes. So this morning we were actually doing the Pythagorean theorem, and a couple of people were like, man, I really need to go over those square roots again. So what I'm going to do is take it a step further. We're actually going to simplify radicals. So radicals is a combination of square roots, cube roots, fourth roots, fifth roots, seventh roots, eighth roots, 10th roots. But I'm not going to go that crazy. I'm just going to try to keep it within the realm of square roots and cube roots, because that's what you're going to see basically on the GED, the ASVAB, the Accuplacer, and the TEAS test, and any kind of standardized assessment. So for those that don't know me, my name is Audrey Codner, and I'm the owner of Math by Audrey, and I come on here to basically give adults, so when I'm saying adults, I'm talking about maybe 25 years and up, just that confidence of going back to school, the confidence of facing the math that they're facing, and be able to break those concepts step by step. So, as I said, we're going to be doing simplifying radicals, and let's take this one step at a time. So, when you simplify radicals, you always want to break it down in what I call the perfect prime combination. So when we're looking at, say, the square root of 49, we want to get a perfect and a prime, two numbers multiplied together that will give us 49, but one of them is going to be a perfect square root and the other one is going to be a prime number. So if we need to revisit prime numbers only factors is 1 and itself. So that's why when it comes to prime numbers, the first prime number is a 2, not 1. Okay, so the first prime number is a 2. Then you have 3, 5, 7, 11. Okay, so it's not all odd numbers. Okay, so 2 is not an odd number. It's basically anytime if I try to do multiplication, the only way I can get these numbers is when I multiply this number and 1. That's it. Okay, so the only way I can get a 2 is 2 times 1. The only way I can get a 3 is 3 times 1. The only way I can get a 5, a product of 5, is 1 times 5, and so on. Okay, so let me continue on with my dots. So now, here we go with our breakdown. So if we're looking at the square root of 45, we want to try to get as best as we can to break down a perfect square root times a prime square root. So if we really think about this, way that I can get 45 that I know of is 9 and 5. Right? So here's my thing. The square root of 9, that's a perfect square root. So the square root of 9, which gives me 3 squared in the reverse, is just simply going to be 3. Because the 3 squared gives me my result of 9, and the inverse of a square is a square root. So the square root of 9 gives me a whole number of 3. Okay, no longer you have to put it underneath a square root. Now, the square root of 5 cannot be broken down because it's not a, it's basically a prime number, okay? So when we take a look at the square root of 5, if we can't break it down, we simply bring it down. Okay, so when we do this, we have our answer of 3, the square root of 5. Okay, so you want to get real acquainted with your factors. Get that multiplication. Now, if you ever get stuck with your multiplication, that's why I have this one resource. So my resource is my factor sheet. So if I'm looking at 45, here I go. I have 1 and 45, I have 3 and 15, and I have 5 and 9. Notice the 5 and 9 is in red. So if I break this down, and this was the coding for it, case of the key, a perfect prime combination for factoring. And also you can use it to simplify radicals. Alright, so if you wanted to do 3 and 15, that means you need to break down the 15 because 15 is not a prime number, nor is it perfect. Okay, so that's telling me I need a higher number. So that's where we got our 9 and 5. Alright, let's try another one. Switch our colors a little bit. Okay, so we can go another simpler one. We'll go with square root of 50. Now, with the square root of 50, we are looking for a perfect prime combination. And I know sometimes right away a lot of people see the 0 and instantly they're saying, oh, well, I know that 5 times 10, even if they're radicals, will give me 50. But then you're going to have to break that 10 down again. So now you're going to have 5 times 5 times 2. Okay? So this 5 in front came from the 5 right there. But then we notice that 5 times 5, that's the same as saying 5 squared. 5 times 5 will give me 25. And then I have my times 2. So we could do with the 5 and 10, but we'll have to break down. Or we could just get right into our perfect prime combination. So we have the square root of 25. And then 25 times what will give me 50? Times 2. So if you can't see it from the beginning, try to break down what you know to see if you can get a perfect square. Because 5 times 5 is the same as saying 5 squared. Okay? So now with that, we're going to break down. The square root of 25, since that's a perfect, it gives me a whole answer of 5. And now the square root of 2, since 2 is prime, if we can't break it down, we simply bring it down. Okay? So our solution is going to be 5 square root of 2. Alright? I appreciate it. She's like, I'm 40 years old watching this. Oh, trust me, I usually have people that are in their 70s and 80s watching this. So you're young. What's up, young buck? Okay. Just made up shenanigans? Alright, Steve. I appreciate you. But now that you wrote something in my timeline here, now you're always going to see math stuff. Congratulations. What's up, cousin? Alright. Okay. So, breaking on down. Hello, Jackie. I did get your message. Keep going, girl. Okay, don't worry about this. Don't confuse yourself. Keep going with the pattern because you're about to hit on this, okay? So now, let's see if we can break it on down by looking at the cubic. The cubic is what throws a lot of people off because we're so used to looking at square roots. Now we got to think in terms of raised to the third power. We got to think of cubes. So now we're going to do the same exact thing. We need two numbers multiplied. But now we need to think in terms of the cubes. So if we don't have our cubes down, let's take a look at our listing here. Oops, moving stuff around. All right, so if we got our cubes and our cube roots, So 1 to the third power is 1, 2 to the third power is 8, 3 to the third power is 27, 4 to the third power is 64. Now, if we're looking at an answer of 54, well, obviously we are not going to go anywhere near 4 to the third power, because 64 is bigger than 54. But let's take a look at this 3 to the third power, which gives me 27. Now, could I divide that 54 by the 27 to give me a whole number? Okay? Is that possible? Is that possible? Okay? Steve, don't forget the T in math. Is that possible? Yes, Nat. So what do we get? So if we have 54 divided by 27, what do we get? Okay, Carrie, I see you as well. So if I take 54 and I divide it by 27, what would I get? Is that Catastrophia? Okay, Nat, I see you. Catastrophia, I see you. Nat Curly, I see you. Okay, Carrie, I see you. All right, I see you. Mercedes, good, I see you. Yes. So, this is telling us 27. So, knowing my perfect cubes, I tried to divide it with the number that's it's called a radicand. To divide the radicand by one of my perfect cubes. Or sometimes, if I notice it ends in 4, that means it's even. If I take that 54 and I divide it by 2, and I get a perfect cube answer, we can look at it that way. So now, the cube root of 27. So the cube root of 27, which we just found, 3 cubed, will give us a whole answer of 3. Okay. But now the cube root of 2, since that's prime, if I can't break it down, I simply bring it down. So your answer is going to be 3 times the cube root of 2. So my suggestion when you look at these, take a look, and this is called the index. If you don't see anything here, it's considered a square root. If you see a 3, a 4, or 5, it's going to be that type of root. So since there's a 3 here, this is considered a cube root. If there was a 4 here, it's a fourth root. 5, 10, 256, yes, they all exist. Okay? All right? How can you purchase the book? There is actually a link in my profile. And I can show you close to the end, or I can show you right now. All right, so why have you waiting? So if you go to my profile, just click on my profile pic, and there you have Stan Store. If you just click on that. And if you're talking about my notebook that I have here, you're going to have to go all the way to the bottom because those are where the books from the A's are. You can only get this book, particular book over on the A. Okay? You're probably saying, what's the A? So if you want to get any of the physical books, you just have to go here. Okay? Alright? Yep. So if anything, this is called the Ultimate Math Notebook. Okay, so you might have to do a search on the A. Alright? So, cubes are harder than squares because you don't get too much exposure with the cubes than you do with the square roots. So we really have to practice up on, if I may, understanding your perfect cubes. Not only that, understanding not only your perfect cubes, but also understanding your perfect squares. Okay? So all of these are generally listed in most of my books, okay? So even if you get the Algebra at Your Pace book, this is in there, as well as the listing of the factors. And my factors go all the way up to 200. Okay? All right, perfect. All right, so let's take a look at another one. So we're looking at the cube root of 81. So we have to think in threes. So what number multiplied to itself 3 times can either get me 81 or get me close to 81? So if we think about it, we have our 2's to the third power. So that's 2 times 2 times 2, which gives us 8. Then you have your 3 to the third power, which is 3 times 3 times 3, that gives us 27. Then we have 4 to the third power, so that's 4 times 4 times 4, so we have 16 times 3. Would that give us our 81? Carrie Star is saying 4. Okay? Because 4 times 4 is 16 times 4 is 64. And we know that 5 cubed, that's 5 times 5 times 5, that gives me 125. So anything dealing with the 5's will be way too much. Okay? The name of the book is The Ultimate Math Notebook. And if you also do a search on Audrey Codner, you'll see it. Okay. You're so welcome. Let's see if I can pin it for you. There we go. All right. So I know we're so used to seeing the square root of 81, and a lot of people want to say 9. I know it's hard. It's really hard. Okay? It's really hard. But we have to think of 2 numbers multiplied that can give us this 81. So we could kind of take it on a division type of trip. So we know 5 cubed is not going to help us because that's more than 81. Okay. And if I try to take this 81 and divide by 64, that's odd number. This is an even number. That's definitely going to give me a decimal. So let's see if we can play around with this 27. 81 is an odd number because it ends with 1. 27 is also an odd number because it ends with 7. What's 81 divided by 27? You're so welcome. What's 81 divided by 27? It's under the first one. Hey, Pookie. Okay. Right? So it gives you an answer of 3, right? So we just found our 2 cube roots. Excuse me. So we found our perfect, which is the cube root of 27. And we found our prime number, which is 3. Because 27 times 3 gives us 81. So the cube root of 27, that's 3, a whole number of 3. And then we have the cube root of 3. Well, 3 is a prime number. We can't get anything out of it. We won't be able to break it down like we did with the cube root of 27. So if I can't break it down, I simply bring it down. So my answer is 3 times the cube root of 3. Okay. Alright. So it's really kind of knowing the multiplication, really kind of knowing your perfect squares as well as your perfect cubes. They like to sprinkle in some cube roots in there, but they also will kind of challenge you a little bit if you're taking the GED or especially the ASVAB and the Accuplacer, that they'll have you break something down by the sum or the difference of cubes. So knowing your cube roots, those I would say at least up to 5. If you can get it up to the 6 cube, that would be awesome. Okay, to really understand and memorize those. Okay. So this is just dealing with it as numbers. But there's another step. Okay, there's another step. So what we have here, what happens if we have variables? You're like, oh no. Let me bring it back to square roots. Okay, so say we had the square root of x cubed. And they're telling you to break it on down. Well, if we're talking about square roots, think of it like this. Say you have 3 boxes or 3 items, and you can only ship them out when there's 2 items per box. So if you know that the inverse of a square root is a square, we can do it like this. We can break down to x squared times x to the first power. The reason why, if I do multiplication, I normally add the exponents. Right here, if you don't see anything, the exponent is going to be a 1. Okay? So 2 plus 1, that's where this 3 came from, but we had to do it in reverse. So I tried to split them up in groups of 2. The reason why I'm doing it in groups of 2, because it's a square root. Okay? So now we have the square root of x squared I don't tolerate rudeness. Okay. So we have an x squared. So if you want to think about it as a square root of x squared and the square root of x, put them in their own square roots. Here you can see the inverse is happening. So a square and a square root, they're opposites. They're inverses. So they're basically canceling each other out. What's left over here is just simply the x. Okay? Squares and square roots are inverses of each other, just like adding and subtracting are inverses, and multiplying and dividing are inverses. So what's left is the square root of x. So if I can't break it down, because this is a square root, that means in order for me to cancel things out, it has to be a square. But it's 1 left. So if I can't break it down, I bring it down. Okay. Thanks, MJ. Okay. So it's little steps like this. So let me show you a little combo. Just a little combo. So I'm going to stick with the square root. I have my square root of 32, x to the 5th. Now I know when people see this, they're like, oh, nope, I'm out. But no, we're going to break it down step by step. First off, give each their own radical. What I mean by that is we're going to take the square root of 32 Then we're going to take the square root of x to the 5th. And we're going to treat them separately. Don't worry, they're going to bond together at the end, but we're going to treat them separately so you won't get overwhelmed. So if I cover up my square root of x to the 5th and just focus on the square root of 32, now we're going back to finding our perfect prime combination. So for 32, what would be a perfect prime combination? What do you think? What gives me 32 through multiplication? Now, if you're not sure, we can go to our lovely little chart. And we can go to 32. Okay. So then here we go for the factors of 32. We got 1 and 32, 2 and 16, and 4 and 8. There you go, Jazzy. Thank you. Okay. All right. Not a problem. All right. So you could do 4 and 8, but guess what? 4 is perfect, but 8 is not prime. So that means I'm going to have to break down that 8 again. And for me, I guess I'm lazy. I just like to go for the largest one, so I'll have a little less steps. That's just me. So, but we have 2 and 16. Now 16, that's a perfect square root, and 2 is definitely a prime number. It's the very first prime number, to be in fact. So let's try 16 and 2. Let me cover this part up. So 16 is going to go here, and the 2 is going to be here. I like to put my perfect in front because it's going to naturally be a whole number, so it will be in front of the radical. Because if you put the perfect behind, you're going to assume, oh, I got to break that radical down again. And then you're doing extra work because you're working your way into a wrong answer. Okay? So make sure you put it in front. So the square root of 16, that gives me a perfect 4. Okay, no more radicals, a whole number of 4. And that square root of 2, since 2 is a prime number, if I can't break it down, I'm simply going to bring it down. Okay, so this will take care of the square root of 32. So now, let's sashay our way over to x to the 5th. So the square root of x to the 5th, well, we're dealing with the square root. So we want to see how many square roots are involved, or how many squares, excuse me, are involved with x to the 5th. Well, you have x squared here, you have another set, x squared, and then you have 1x. So if you think of it like there's 2 x's here, there's 2 x's there, there's 1 x there, so that will give me a total of 5 x's. So if you want, you can put them each in their own radical. Okay, this is just so you can see the steps. So if I do the square root of x squared times the square root of x squared, and then you have your square root of x. Well, like we said earlier, where's my red? There it is. We have squares and square roots. They're inverses of each other. So that means they're gone and they're gone. So what's left? X times x times, now we have the square root of x that's left over. If I can't break it down, I'm going to bring it down. But let's clean this up. Okay, let's clean this up. X times x will give me what? Okay, x times x will give me what? Because we can combine those two. Alright, Pookie, I see you x squared. Okay, Carrie, I think you're probably looking for the 2, which I hope. Alright. Okay, so x times x, there's the 2. There it is, Carrie. Alright. When you're multiplying, you're adding the exponents. Okay? So there is assumed that there's a 1 as an exponent there, and a 1 as an exponent there. So 1 plus 1 gives me x squared. Okay? Alright, gives me x squared. So x times x does not give me 2x, that's adding. X times x gives me x squared. Now we have the square root of x. Because if we can't break it down, we bring it down. So now let's clean it all up. So what we have here is everything that's not underneath the square root, we're going to gather together. And everything that is under a square root, we're going to combine together. Okay? This is just an extra step so you can see where everything's coming from. The 4 came from here. The x squared came from here. The 2 that's under the radical comes here. And the x that's under the radical is coming here. Okay? Hello, MBM. Alright? So when you basically multiply them together, you get 4x squared and then the radical of 2x. Okay? So really knowing your multiplications, really knowing your perfect squares and your perfect cubes will help you break down the radicals. But what I did, what is a radical? It is like anything a square root, cube root, fourth root, anything that gives you this signage. That's a radical, okay? Because a lot of people say, oh, that's a square root, but it's a square root now because I didn't change, I didn't change its index like we did for this cube root. So if you don't see anything, it's going to be a square root. But if there is an index there, that's the type of root that you're going to have. Okay? Alright. So, this part. Okay, so let's try one more just to make sure we are okay. We're understanding to the best of our ability. So let's go with, I'm going to put example 7 over here. Alright, so I'm going to stick with the square root just so we can get used to it. So we have the square root of 28 x to the third y squared. Okay, hey Florence. Alright, so breaking on down. Very first thing, put your coefficients with their own radical, and then your variables with their own radical. So we have our square root of 28. Then you have the square root of x cubed. Then you have the square root of y squared. Okay. Yes, this is definitely algebra. Okay. So I got the square root part. Okay. So now we have the square root of 28. So we want to break that down into two radicals. One being perfect and the other one being prime. So what is two numbers we can use to multiply to give me 28? One of them is a perfect square root and the other one is a prime square root. Okay, Dom, I see you. Hi, Dom. It's been a minute since I see you. JT, I see you. 7 and what, JT? Okay, Carrie. Okay, there you go. Thank you, JT. Thank you, Carrie. You were like, I'm about to type it. Don't say it, lady. Jazzy, thank you. All right, so 7 and 4, 7 and 4. We got 3 people that are saying 7 and 4. So my 4, since it's perfect, I put it in front. I know, it's very conceited of us. And then the prime is the 7 follows through. The reason why I put the perfect square root in front, because the square root of 4, that gives me a whole number of 2. Now that square root of 7, that comes down, because if I can't break it down, I'm going to bring it down. If I put that 2 back here, your eyes and your brain will read it as a square root of 72. No matter how hard you try, that's exactly what it's going to do. And then all of a sudden, you're spending all this time breaking down the square root of 72, and you're breaking it down to a further incorrect answer. Okay? So now, that square root of x to the third, we need to break up those exponents. Now here's a secret. Ready? If it's an odd exponent and you're dealing with a square root, just pull one of your variables out. Just subtract 1 from that exponent. So 3 minus 1 will give me 2. So that means I have x squared in the other variable. Okay? Same thing kind of happens up here. Remember we did the square root of x to the 5th? 5 is an odd number. So if I just want to split up my 2 radicals, this is going to be the 1. Subtract 1 from the 5, that gives you x to the 4. Okay? And since it's a square root, we could actually divide 4 divided by 2 to give us x squared. Isn't that what we got down here? Okay. So now when we come here, we have a square root and a square. So square roots and squares, they're inverses of each other. They cancel out. So what's left is my perfect x. And then I have the square root of x left. So whatever I can't break down, I bring down. Okay. So now we got the square root of y squared. It's a square root. Square roots and squares, they cancel each other out. So what comes down is just the y. So now all we have to do is clean this up. Anything that's not under a radical, make it into your 2, your x, y, and then you gather everything that is still under a radical, which is your 7x. This is your answer. Okay. Why? What do you mean? Because if I cancel out the square and square roots are inverses of each other, that means you get a whole letter of y. Just like if when you cancel the square and the square root for this x, and you get a whole letter of x. So y is not underneath the square root anymore. So what you're doing is all of this is multiplication. So you're going to multiply the 2, the x, and the y. And then under the square root, you're gathering everything, which is the 7 and the x, and put it down in one square root. Does that make sense? Okay. Yep. Helped you a lot? Oh, good, Jazzy. Good. All right. So this is what happens. If you feel like, you know what, I like this, I really want to do more practice with this, I want to look at a little bit more with the cube roots, I would love to do that. That's why I have my Algebra at Your Pace books. Okay. So, so with our Algebra at Your Pace books, it's not just a regular workbook. It's actually something that guides you through the whole process. It's great that you're able to see these lives. If anything, you just hit a Scantron, and then each topic I come on as a video and I break down steps. I break down examples. And then after you learn, okay, after you learn, yes, we had to combine the square roots. So after you learn, you got some extra practice problems, and at the end of this whole volume, you will get a sample quiz, just so you make sure you solidify all the information that you're finding, okay? And then, like I always have, various stuff in the very back to kind of help you, remind you about the rules, the integers, okay? See, we have the squares, the square roots, the cubes, and the cube roots, so we can put all this stuff together. Yes, so we're just, because since it's multiplication, you can merge them together, because that's what you're doing. In order for us to figure out the 28, oops, let me turn it that way. As long as we had to figure out the 28, we had to figure out what two numbers multiplied gave us. So that's what the 4 and the 7. We're basically doing multiplication of all of this. So you only can combine, you know, likes with likes. Okay. All right. So if anything, if you need something to start from the very beginning and you really want someone to break down concepts, I also have just the books, but then you also have the video breakdown. So like if you say, all right, Audrey, I need the books, like everything you got, even the practice books, because here's my thing, guys, we're here on the live and you're understanding a lot of these concepts as I'm going through it. But what are you going to do once I shut this live off? Okay? All right? No, I don't do calculus. That's just not what I want to do. Okay? Because I focus on the people that really need me with the GED. GED, the ASVAB, the Accuplacers, because that's where my heart is. So as we're breaking down all these concepts, you need to practice so you can solidify it in your brain, because all it takes is one cat or dog video and then all this stuff just goes shooting out your brain, right? So that's why I also offer like practice books. Here's our practice exam books. You get 6 full-length tests with solutions. And if you need something for my ASVAB people, and this is open to everyone, but if you need some for the ASVAB, you just need some practice exams, you need to sit down and do a mock test, you can sit down and do a mock test so you can, one, practice taking something with time. Now, people that are taking the ASVAB, you're basically given 1 minute per problem. People that are taking the GED, the Accuplacer, you're given like 1 minute and 10 seconds per problem. Okay? All right? So this is you actually go crazy when you leave. Okay? So it kind of gives you that extra practice. All right? Not a problem. All right, so if anything, if you have questions, and I know for right now, we've done a good handful of math, and for most of you guys, it's been a lot of math because you haven't done this in forever, right? So now, when I'm sitting here talking about books and all that stuff, it's all fine and dandy. But if you are about to take an exam, GED, ASVAB, Accuplacer, TEAS test, HESI test, SAT, ACT, and you need to revisit a lot of the foundational math, make sure you message me. Let's get together and devise a plan. Because a lot of you guys are saying, oh, I got to take my test next week, so I'm just going to keep watching videos. Because watching videos is not solidifying it. Because as soon as you sit down in that room, just driving to the place where you're about to take the test causes a lot of anxiety. No matter how you try to be super chill about it, you're going to be anxious. And then you're waiting in line to get checked in, you're going to be anxious. Then you go find a seat, you're going to be anxious. So now you're already at a 10, if not a 12, before the test is even in front of you. So you want to practice, hey Amber, you want to practice the way that you're going to test. So when you go into this situation, you're not letting your nerves, your insecurities that you made up in your brain, and all things to affect you doing well on that assessment. And that's where it comes through guided practice. Not just practice. You can just sit there and practice all day and you're probably going to do the same stuff each and every time because you feel comfortable with it. Yeah, I know I'm calling some people out and they're probably leaving because they're like, ooh, that was a little too real. Hey, and that's fine. Because you're going to keep practicing the stuff that you already know. And then all of a sudden you find yourself looking in the backs of the books and you're memorizing instead of studying. So in order for you to study, you need to one, know what is going on. In order for you, and I mentioned this morning, in order for you to understand the tips and tricks that people are basically showing you guys, especially on this app, which is great, but if you don't understand the basic concept behind it, you're not going to understand when to use that tips and trick, and then all of a sudden you're going to sit there at the test like, what did that person say? Oh, what did he say? How did he do that? And you're spending so much time trying to remember what was shown to you how many weeks ago, instead of just learning it, processing it. We spend so many hours trying to figure out ways to get out of stuff. Instead of just do it, you would have been over and done with by now. Okay? General math, enter in the program. Okay, good. So this will be perfect for you. Okay, so this will be perfect for you. If you need help with like basic math concepts and you need help with rational functions, radical functions, a little bit of geometry, meaning area, perimeter, circumference, as well as how to read graphs, then you have a little statistics, mean, median, mode, and range, which range is not a measure of central tendency, it's a measure of variance, but we'll talk about that later. And we're looking at combination, permutation, as well as volume, surface area. All those things are in my 10-book series, all of them. So if you want that and you want the practice books, there is something that I'm giving all of this, okay, plus my 10-book series. And you can also get it with a answer key, or you can get it without a video answer key. So again, oops, where'd my thing go? Okay. So again, if you go to my profile, all right, and you see right here where it says Stand Store, Math by Audrey, just click on that. And you can stroll and take a look. Now here's another thing that I want to give you. There's two things actually. One, if you look in between Facebook and LinkedIn, there is the YT channel. If you click on that YT channel, I don't know if my fat fingers got it. Okay, here we go. If you click on that YT channel and just scroll up just a little bit, you'll see TikTok Lives. All of my TikTok Lives, I've been here for over a year, almost a year and a half, but definitely over a year. And all of my TikTok Lives are found here. So if you need some kind of quick adjustment, some quick fix, like, oh, here we go with the Pythagorean theorem right there. Here we go with the distance, rate, and time. Okay, all of those things are listed for you. So that's one place where you can go. Now, another place I would love for you to go is, sorry about blinding you guys, is right here with the free math checkup. Okay, there we go. So I have a free math checkup. So you can definitely take a look. And it gives you like a little breakdown. And all it is just like 10 questions to see where you are mathematically. You might be shocked and surprised. Okay? So if anything, You just have your name and your email. I'm not going to abuse the email system because trust me, I know how everybody's busy. And it gets downloaded for free and shown into your email. Okay? So if you're interested in those, go ahead. But if you're like, I think I want to talk to you first, please, no matter what, go to the profile and just send me a message. Okay? I'd rather you send me a message. Hold on, let me talk to you like a human being. There we go. I'd rather you send me a message. Tell me what test you're trying to prepare for, what you've been doing to prepare for it, so we can figure out, hey, when are you planning on taking it? Because you might be just only points away and you're thinking in your mind, oh my God, this test is terrible. And you might just have to tweak a couple of things. Or if you feel like I just need a general refresher, something that will be there and someone can support me along the way, that's another thing. You get to pick and choose what your support is. But here's my thing. Click on my picture, send me a message. Do it now while it's still fresh in your mind. Okay? So we can sit and chit chat and figure out where do you want to go. Because I want this to be the last thing that you need in order to pass your exam. Because I've had people take their GED and pass and graduate. I don't think Janice is here today, but usually she's there. She passed and graduated. She did a lot of work with it. So it's not a matter of, oh, I need a tutor. Unless you're putting the work in with it, it doesn't matter if you have a tutor, yes or no. Okay? But having someone that's going to guide you and you're taking it and running with it and you're studying with it, that's exactly what I want you to do. Okay? So let's chit chat. Go ahead and message me. So you'll contact me? All right, perfect. Because if not, I'll hunt you down. And I'll send you a message like, hi, what happened? What's going on? What do you need? Because I know sometimes a lot of us just need that extra foot to get a little kick in the butt. All right? We're doing this with us. Oh, no problem, Pookie. See, here we go again. Earlier I had a couple sugar daddies and big daddies and big daddy greens, and now I got a Pookie. All right. Yes. So if you need me, please message me. Even if you're just like, Audrey, I like you, but I don't want your stuff. I already got a program, but I'm just kind of curious, like, am I going in the right track? Message me. I don't care. Like, I know I put a lot of blood, sweat, and tears in the books. Got that. But at the same time, the reason why I do it is to make sure that people like you are not going to kind of give up on yourself. That's what I don't want you to do, because I was in that position. And that's why I was like, you know what? I don't want anybody to feel that way. Don't be down on yourself. Give yourself grace. Don't say to yourself, oh, I'm 42 and I should have my GED by now. So what? Now we got the program. Now you can get it. Now you can get your high school diploma. Now you can get whatever you need to pass so you can go to college, get all the other stuff, and then move on. Take whatever career you want to get. But see, my thing is sometimes we just need to get out of our own way. That's the problem sometimes. We are our biggest critics because we keep listening to everyone else. We keep listening to our mothers, our fathers, our brothers, our sisters, our friends. Our friends just want us out because they want to go to the bars. What are you going to do at a bar? Everyone there is escaping from something. Why you want to get picked up by someone that wants to escape from something? Think about it. Okay? So, let's go. If you need me, go ahead and click. Go ahead and message me. And I'll see you guys tomorrow morning. All right? Take care. Bye.